Here we are again. This lesson introduces us to the 3 practical cases prepared for you, which we will see in the next videos. We are ready to discover and make a detailed analysis of how to set up a tuning procedure for an original file coming from a diesel engine. In addition to this, we will examine the substantial differences between a standard and a customized approach, specific for the control unit and the modified vehicle, within each section of the practical cases, or for the tuning practices available online. Let's start by asking ourselves a question. Why are the tuning examples based on the ECU brand and model? Let's take a step back and begin by saying that everything starts from the design that an automotive group wants to develop. The group commissions a group of engineers to perform the calculations, the subject of the previous videos, and thus be able to create an engine that respects the technical characteristics, performance, and, above all, the emissions required by the manufacturer. Very often, each automotive group relies on its trusted engineers, and this translates into operation strategies of the diesel engine control units that are very similar to each other, even in the case of a different ECU model. If you are still confused, don't worry. Now, let's clarify the concept with an example. The BMW Automobile Group developed the B47D20 engine with 2.0-liter displacement and subsequently installed it in the group's vehicles starting in 2014. To reduce production costs, this engine uses many components in common with the B37D15 version with a displacement of 1.5 liters, including the engine control unit. The flexibility of this design, therefore, allows 2 different displacements and management of various powers ranging from 70 kilowatts to 170 kilowatts. According to the power, therefore, the engine design remains unchanged, but the manufacturer can change the mechanical or hardware elements, such as the injectors, the turbine, the intercooler, and even the number of cylinders, or, at the software level, for example, the original file written inside the engine control unit to generate more or less power. It is therefore understood that with the same engine and ECU design, the operating strategy of the engine control unit will remain unchanged, and for this reason, the tuner will be able to adopt the same modification procedure for other engines, even with different powers, but equipped with the same engine and control unit design. From this pivotal point, Alientech technicians also prepared their own tuning, subsequently adapting some specific modifications based on the mechanical components used by the manufacturer. For this reason, therefore, it is possible to exploit the strategy used by the manufacturer to create more or less powerful versions, comparing the 2 original files by means of a tuning software, ECM Titanium, and verifying the differences present within the maps. If the 2 engines are identical in terms of mechanical and electronic components, it is possible to copy the differences from the higher power version to the lower one, and then modify the file maps using the specific strategy provided for that type of ECU. We Alientech technicians prepare our remapping by adapting specific tuning operations based on the mechanical components used by the manufacturer. What if the engine design remains the same, but the ECU brand and model change? In the event that the automotive group commissions a manufacturer to develop its engine control unit, the modification strategy used by the tuner will also have to adapt to the changes, since the operating strategy used by the control unit will change slightly. In fact, it happens very often that the automotive group changes the ECU brand and model, keeping the engine design unchanged, for 3 main reasons: serious problems encountered with the ECU manufacturer, costs, management of emissions. The first point is based on a question of reliability. If the automotive group encounters various serious problems with the ECU, that cannot be solved by a simple software update performed by an official diagnostic tester. It will solve the problem by replacing the initially designated control unit developer to be able to offer a reliable motor system without having to change its production line. With regard to the choice of the vehicle manufacturer for the development of the engine control unit, the main purpose of the automotive group is to consider the cost to be incurred and thus be able to obtain the best value for the money. Subsequently, in the event that another manufacturer of electronic control units offers a better quality-price ratio, the automotive group will replace the control unit used on a specific engine design and continue to use the same mechanical components. As a third point, we have the management of emissions. In the event that laws require increasingly stringent emissions and the developed engine is already able to meet the limits imposed by the regulations, but the ECU used does not have the capacity to manage any additional anti-pollution systems, the automotive group will necessarily have to replace the ECU with a better performing one or add additional control units to the new systems, used only for controls of this type. Precisely for this reason, we can find various old generation control units with relatively simple original files and a reduced number of engine management maps, simply because the emissions regulations in the past did not provide for complex anti-pollution systems, so even the ECUs were not technologically cutting edge. With the passage of time and with increasingly stringent emissions regulations, engine control unit development technology has required update in order to use very complex original files and a greater number of precise and detailed maps. They also manage the new anti-pollution systems, such as regeneration of the particulate filter or the use of the SCR system, which we examined in the previous videos. Given the concepts seen above, let's see why it is necessary to change some specific maps in a certain type of file that have maps that are very similar to each other, rather than other maps in different files. By now, we know that the manufacturer very often uses the same control unit for a new engine design, but based on various conditions, it can keep the same engine but replace the control unit that controls it, thus varying the operating strategy. For this reason, it is necessary for the tuner modifying a file to adapt his modification strategy based on three main elements: automotive group, ECU brand and model, engine control strategy used. Very often, in fact, the manufacturer customizes the structure of his original files and uses common maps even if the control unit brand and model vary. So, for those brands that customize their files, you will often find the same maps to be modified to increase engine performance, even if they use different ECUs. Regarding the second element, however, the operating strategy of the ECU is often the same for the same control unit generation and version. Therefore, regardless of the automotive group, in the event that the brand and the generation of the ECU are identical, there will be many maps in common, even between different car groups, and it will therefore be possible to use the same modification strategy. Regarding the third element, let's take a look at it. Based on the engine control strategy adopted by the manufacturer, which maps we should modify to increase the performance of a diesel engine. Starting from the oldest ECU, we have seen that the number of maps used to control the engine system is very limited, which translates into greater simplicity of operation. Fewer maps, fewer checks to do. Let's take a look at the main map, called the fuel quantity request, that the old generation control unit uses. In this map, the fuel demand depends on the engine speed and the accelerator pedal pressed. With the new generation of ECUs, looking instead at the intermediate strategy, which is the one based on the torque calculation but without the torque monitoring control, the number of maps used increases considerably, and consequently, both the correct function and the modification of the maps become more complex. Here we can see an example of a map with the torque request, which can occur in various conditions: standard, during acceleration, or for each single gear, depending on the engine speed and the accelerator pedal pressed. Furthermore, thanks to these maps, it is possible to maintain optimum control and maximum efficiency of the main systems present in the diesel engine, such as the amount of fuel quantity injected to develop the engine torque required internally as a function of the engine speed. And in turn, the maps relating to the management of fuel and air pressure inside the intake manifolds allow you to control systems such as the injection time, which controls the opening time of the injectors, usually expressed in milliseconds or microseconds, and as a function of the amount of fuel injected and the pressure inside the rail. The injection timing, which adjusts the opening moment of the injectors according to the engine speed and the quantity of fuel to be injected. The rail pressure, which determines the pressure with which the fuel will be injected into the combustion chamber as a function of the engine speed and the fuel to be injected. And the turbo pressure, to adjust the turbine pressure and, consequently, the airflow entering the engine, according to the engine speed and the fuel to be injected into the cylinders. It should also be noted that car manufacturers very often already calibrate the main maps to achieve high performance. Therefore, in that case, it will be necessary to simply unlock the limiters, which could limit the quantity of fuel to be injected or the engine torque that can be delivered. Finally, the last question to which we must find an answer is, what are any elements and reasoning common to all tuning procedures? We can say that there are various common elements to take into consideration when the tuner performs a tuning, and consequently, when the modification procedure is applied. Alientech technicians also perform various tests and check various parameters to adapt their standard procedure, or base, to the specific vehicle to be tuned. The most important elements to be checked can be checked quickly, using even a very basic diagnostic tool, as they are shown using the universal EOBD protocol. Among the most important elements to check, we find diagnosis of the reading performed by the pressure and temperature sensors in the exhaust system, because an incorrect measurement of these could cause the engine to run inefficiently or even bring it into limp mode. Diagnosis of the reading performed by the MAF and MAP sensors. Remember that air is one of the most important parameters for efficiently regulating the carburation of a diesel engine. An incorrect calculation of air can therefore affect the correct operation of the engine. Diesel particulate filter filling percentage. The percentage should be less than 90%. Last regeneration event. Diesel cars usually have a precise distance programmed in the ECU relating to the last regeneration that took place. It is best to start the tuning process immediately after the filter regeneration event. Check coupon warning light. If the car needs an oil change or something else, you must ask the owner to do it first. It is best to start the tuning procedure immediately after the routine vehicle maintenance. Oil level. If the level is above its maximum, first check the engine coolant temperature. Then, if the engine is hot, check the level again when the engine is cold. Under certain conditions, excess oil can affect the calculation of engine torque loss, thus resulting in inconsistent performance. Oil degradation. If the quality of the oil is degraded or diluted, the oil must be replaced before the regeneration can be performed. Soot content, sometimes referred to as DPF fill percentage. After regeneration, the soot level must be lower than the value defined before regeneration. Ash level. Ash is what the regeneration leaves after burning the soot. Some diagnostic tools can recalculate the ash level based on a mathematical model preset by the manufacturer inside the control unit. AdBlue level. check if the AdBlue in the fuel tank is sufficient, and if it is not, check the cause. Otherwise, the ECU will activate the protection mode and will not allow the development of the maximum torque and power. Calculated engine torque. It is always a good idea during diagnosis to check whether the torque defined in the file written on the control unit is actually developed. This can also be considered as a parameter that defines the quality of our tuning. To conclude, we can say that we have analyzed all the elements that allow us to understand why a standard modification procedure is not always used. Furthermore, we have seen cases where the editable maps are subdivided according to the vehicle manufacturer, ECU brand, and model, and why some maps are modified in specific files rather than others. We have analyzed the maps common between manufacturers that are to be modified based on the engine control strategy. And finally, we have listed the general elements and reasoning to take into consideration when performing a specific tuning. Now we just have to look at the remapping practices prepared and tested by us here at Alientech. See you later!